My name is Arun and I'm back with another video. It is on data fundamentals. So let's see what all we are going to cover on this data fundamentals. So this is the agenda that all the topics that we are going to explore. We will cover what is data. Before we start exploring, we should know what it is, and then the data formats, and then we'll explore data storage, and then file storage and databases, and then finally transactional data processing and analytical data processing. It is not a deep dive video, but this is a video which will help you understand data in various kinds in order to explore a data deep dive in the upcoming videos. So let's start with data. So what is data? Well, in simple terms, it's a collection of letters, numbers, or special character, or anything which has some kind of information. Or in simple words, refers to information or facts that can be collected, stored, and analyzed to gain insights or make decisions. Think of data as the piece of information you use to understand something or to answer questions. In the context of Azure, data can take various forms and be used for different purposes. Uh, let's check the forms like structured data. The purpose is transaction kind of data. This is organized data, structured, organized, that follows specific format. For example, think of a spreadsheet containing information about sales transactions where each row represents a sale with column for the date, product, quantity, and price, maybe. In Azure, you can store structured data in services like Azure SQL database, managed instance, or running SQL on a virtual machine, uh, MySQL. There are various services for this kind of structured data that we will explore all of them in upcoming videos for sure. But for this one, let's check what's the another kind. It's unstructured. As the name says, doesn't have a fixed format or structure as we had in this one. So if it doesn't have a fixed format, then what it has, or what all it can include? Well, it can include things like text, documents, images, videos, or social media post. For instance, a collection of customer reviews on a website is unstructured data. We could utilize Azure Blob Storage to store such kind of data. And finally, which is neither structured nor unstructured, but semi-structured. This data falls between structured and unstructured. It has some level of organize and in the form of tags or attributes, some level of organization. Uh, the best example is JSON or XML data used in applications, Azure services like Azure Data Lake Storage, uh, suitable for semi-structured data or Cosmos, like key value or like JSON. Then these are the three variety on the basis of format, structure, unstructured, semi-structured, but this is not it. We do have a data because all these data are residing somewhere. They are stagnant at rest. So what could be another one? Well, of course, moving. Streaming data is generated continuously, such as sensor data from IoT devices or real-time user interactions on a website. Azure Stream Analytics can be used to process and analyze streaming data. Okay, now what all could be there? Well, the very hot topic from last couple of years and upcoming years, big data. Oh, sorry, it's metadata. Metadata is about data about data. For instance, if you have a collection of images, metadata might include information like the data, like date the image was taken, the camera model used, geolocation, etc., etc., etc. It's data about data. And I was saying big data right there. Big data refers to massive amount of data, too large to be processed by traditional data management tools, and Azure offers services like Azure Data Lake Storage and Azure HD Insights to help organizations to build ETL or ELT, extract, transform, load, or extract, load, and transform with the help of various Azure services like Azure Stream, Azure Synapse, or Data Factory, or Warehouse. So these are high level. We understood what is data, what are different kinds, structured, unstructured, streaming, meta, and big. I hope this is interesting and helping to clarify some doubts, or maybe you're learning something new. So let's summarize this slide. It's not the end of the video, this slide. So in Azure, you can use various services and tools to store, process, and analyze data based on your specific needs. These services are designed to help you make informed decisions, gain insights, and build applications that rely on data to deliver value to your organization or users. We choose all the relevant services as per the data we need to store there. For structure, we got SQL. For semi-structure, we got Cosmos. For unstructured, we got Blob as an examples. For streaming, we have Azure Stream Analytics. For big data, we have Synapse. So let's explore the second topic of our agenda, the formats. So data formats are like the rules or templates that help you organize and understand information. They specify how data should be structured so computers and people can work with it effectively. Let's explore some common data formats. As you see on the slide deck, there are like so many kinds and type you have already worked with, I'm pretty sure. Like text data, numeric data. Text data is just like any other text file where we have the information like a list of uh, shopping, like milk, eggs, and bread, or any notes that you create. It consists of like characters, words, and sentences, like what you read in your books or articles. Numeric data includes numbers. Date and time is like date and time. We are using this date and time since kids. And JSON is a way to structure data using curly braces and key value pairs. Uh, XML, it uses tags to define data elements and their relationships. It's often used for storing structured data or semi-structured data. And CSV, we work with that all the time. So we know CSV, comma separated values, another format. Binary data is another format. It's in the form of zeros and ones and is used to represent complex information such as images, videos, and executable files. Then HTML is used to structure and display content on the web pages. You have seen the XML file. It's like greater and smaller than the sign with all the slashes. Then finally, YAML file. If you worked on the Kubernetes, you know how to write those YAML files, manifestation files. It's a human readable format, yet another markup language. That's what we call them. So it's the format on which you'll find data in different. So these data formats help us structure, share, and interpret information in a way that computers and software can understand. You have seen like you cannot like PDF and Word and other formats, right? Depending on the context and the type of data you're working with, you might choose one format over another to make data processing more efficient and accurate, which we will cover later in this playlist of data. So let's see another topic of this agenda, which is data storage. Of course, cloud is the main center of all the conversation of this particular channel. So it will come And it is still coming, like we talked about the Azure services. So data storage is a fascinating topic at its core. It's all about how we store and retrieve data, which can be anything from documents, pictures, and videos to complex databases of information. So let's break it down step by step in simple language. So again, let's discuss what is data storage with an example analogy. Imagine your brain. You learn something new, like a phone number. Your brain stores this information so that you can recall it later when needed. Similarly, computers and devices need a place to store the data they work with. This place is what we call data storage. Since we're talking about the computers, so let's explore all the storage that computer utilizes, like RAM, random access memory, is the computer's working memory. When you run a program or open a file, it gets loaded into RAM because accessing data from here is super fast, but the data in RAM is temporary. If you shut down your computer, the data is gone. Think this HDD as a long-term memory. It's slower than RAM, but it keeps data even when the power is off. Same goes with the SSD and USB and the cloud storage. So HDD, these having spinning disks inside, they can store a lot of data. You might have one in your computer where your files and programs are saved. SSDs are premium quality. These are like hard drives, but faster because they have no moving parts. They use flash memory and the same tech that's in USB drives. And of course, USB drives, small devices you plug into your computer. They're portable and great for transferring file. You store your data there as well. And cloud storage. Think of this as a virtual storage locker. Instead of saving data on your device, you save it on the internet. Example like Google Drive, Dropbox, and iCloud. But if you talk about Azure, there are multiple ways, like Azure storage account, you can utilize that, right? But this is the very fundamental of the data. So we are touching all those points that we should be aware before we explore deeper into the data. So let's take a simple example here. How does data storage work? You click save after taking a photo. The computer converts the photo into language it understands. What it understands? Binary, zeros and ones. The computer then finds a spot on the hard drive or SSD to store these zeros and ones. When you want to view the photo later, the computer fetches the binary data and converts it back into the photo you see. So that's how the storage works, and that's the latency. If things are different, it takes time to fetch and get it back for you. And now here, since I mentioned the word latency, why are some storage faster than others? Well, remember RAM and HDD we talked about. RAM is super fast because it's built to provide quick access. It's like keeping your favorite toys at arm's reach. HDD are slower because they have physical parts that move. Imagine trying to find a toy in a big toy box. It takes time. So to wrap it up, data storage is all about where and how we keep our digital stuff, just like we have cupboards, drawers, and shelves in our homes for different items. Computers and devices have various storage types for data. All right, so now we have pretty good idea about the storage, and this is not it. These are just the example I took, which is like very basic. We belong to the cloud. We're gonna talk cloud, and we know Azure Cloud Storage, all cold and hot, and archive, and Azure Data Lake Storage, and other stuff, right? So let's see what is there in the next topic. Ooh, so many cabinets. Of course, it's going to be file storage. So file storage and databases are two primary methods of storing information digitally. Let's explore them in a similar fashion. File storage, it's like a digital filing cabinet. You have folders, and within those folders, you have files, documents, pictures, videos, etc. And databases, imagine a super organized, powerful digital library. Instead of just storing files, it organizes chunks of data so you can quickly search, retrieve, and manipulate them. Now, if you talk about file storage, let's see some file system. This is the standard way computers organize files on a storage device. Local or network, there are two kinds of file system. Local is, as the name says, local. It's local to the computer. It belongs to the computer, like hard drive or SSD. Network, it's getting from the network, allows multiple computers to access files over network. Like Azure files, we talk about Azure, yeah, and Azure disks. Now the databases are like three kinds that I've mentioned here: RDBMS, which is relational data, NoSQL data, and in-memory databases. RDBMS, think of them as digital tables. Structured data we talked about is all for relational databases: MySQL, PostgreSQL, or Oracle. And NoSQL database not based solely on tables. They can store data in various ways, like key value pairs or documents based. Cosmos DB is a wonderful example for NoSQL database. In memory, these databases use RAM. Of course, these are expensive, but it makes your application run like a super fast Flash. Yeah, Redis can also function as an in-memory database, which is the best, I guess. Then we need to understand how do file storage and databases work. So you create a document and save it. The computer stores it in a location path that you specify. When you need it, you navigate to the location or search for it to open. That's how it works. And database, you want to save a piece of data, say a computer's details. The database, if relational, stores this data in rows and columns and table. In a table, when you need specific data, you query the database and quickly retrieves it for you. That's how it works in the file storage and databases. Now, why use one over other? So it's pretty clear as of now how these things work. So you have a pretty good idea, but let's talk about it. It's straightforward and works best for static data like documents, images, or videos. I'm talking about file storage. If you just want to save a report or a picture, you would use file storage. For databases, they shine when dealing with dynamic data, for instance, on an online store's inventory where products get added, sold, or updated constantly. Here, databases make searching, updating, and managing data efficient. Uh, from a daily life, the example is saving a picture of your a cat or dog or yourself on your desktop. That's the file storage. Ever signed up for online services? Your login details are probably stored in a database. Uh, in conclusion, while both the file storage databases are ways to store data, they cater to different needs. File storage is more about holding on to data, while databases are about managing and interacting with it. Think of it this way: if data were books, file storage would be like shelves where you keep them, and databases would be an intricate cataloging system that helps you find, lend, or even modify the contents of the books quickly. All right, so I hope this is clear. And now let's see what we have. Now it's transactional data processing. So what it is? Well, imagine you're playing with building blocks. Each time you place a block, you make sure it's done perfectly, because if one block is out of place, your entire tower might fall. Similarly, in the digital world, when we handle data like making a payment or updating an account, we want to ensure everything goes smoothly and accurately. This careful handling of data operations is what we call transactional data processing. And it must have some key features. That's why we need it, right? So what are the key features? Uh, Seems familiar. Yes, this is asset properties, atomicity, consistency, isolation, and durability. Atomicity, it's all or nothing. It will not be in between. Consistency is data should be in a consistent state before and after the transaction. If you transfer money, the total money between two accounts remains the same, just divided differently. Uh, Transaction don't interfere with each other. Isolation. Imagine two people updating the same document. Each person's changes are made separately so they don't overwrite each other. And of course, durability, once completed, the transaction is permanent. If you save a game, you don't want your progress to disappear the next time you play. All right. So I hope the key features are clear. Now, how does it work? Well, the very first thing, we start the transaction, begin the action like clicking the buy now button online. Then the execution happens. The system processes the action behind the scenes. It might check if the item is in stock, reserve the item for you, and process payment. And while it is happening, there is a process of validation. The system checks if everything can be completed smoothly. Can payment be taken? Is the item still available? Once the validation is done, then if everything checks out, the transaction is finalized or committed. If there's a problem like insufficient funds, the transaction is canceled or rolled back. So that's how it works. And why we use it? Why is transactional data processing important? Because, of course, for the safety and reliability. Wherever the money involved, there is a chances that threat is nearby. So we need safety, right? So it reduces errors when transferring money. You don't want mistakes. If a system crashes midway, the process can be safely resumed or reverted. You have seen that many times with transaction canceled, but the money deducted, but it will come back. Even in your ATM, when you go and try to take cash, sometimes it says deducted, but All right. So there are some examples: online shopping, ATM, booking tickets. I hope now it all makes sense. So, in a nutshell, transaction data processing is like a safety net for digital operations. It ensures that every step in a process is done correctly and in order. It's like making a recipe. You wouldn't want to miss a step or an ingredient, or the whole dish might be ruined. Similarly, transactional processing ensures every step in a digital recipe is done just right. So, finally, let's analyze something. But before that, we should understand analytical data processing. So let's take another analogy. Imagine you have a giant box of puzzle pieces. Each piece represents a bit of information. Now, instead of simply assembling the puzzle, you want to study the pieces to understand patterns, trends, and insights. You're curious about things like the most common colors, the sizes of the pieces, or the patterns they form. This act of examining and interpreting data to gain understanding is what we call analytical data processing. Now, what are the key features? Just like we had asset properties, it is like it dives deep into data to find trends, patterns, and insights that aren't immediately obvious. Analytical processing often looks at past data to understand trends over time. Unlike simple searches, analytical queries can be more detailed, asking multiple questions at once. Complex queries, because it's dealing with a lot of data in complex queries, it can require more computing power. It's resource intensive, right? So how does it work? Well, gather large sets of data from various sources, collection, store the data in database or data warehouses, storage, use specialized software or query to ask complex questions about the data. Then finally, you can visualize, present the findings in easy to understand formats like graphs or charts, and understand and draw conclusions from the findings. Now, what are the importance? Well, it helps us to make decision on the basis of everything that we have analyzed. On the basis of the description, we can forecast. By understanding the past trends, business can predict future outcomes. Forecasting, it can reveal hidden patterns. For example, a store might discover that people buy more ice cream on hotter days. Insights. And business use it to make informed decisions. For instance, if sales of a product are declining, why is that decision making? Now, if you talk about the examples, we all watch Netflix, so you might have seen the recommended shows. This is what is happening. They're analyzing your Netflix usage and recommending you. Same goes with the Amazon online shopping. Search shoes a couple of times, you'll find shoes all the time recommending you. And the weather forecasting, by analyzing past and present weather data, meteorologists make predictions about further weather. So, in summary, analytical data processing is like being a detective for data. Instead of just collecting information, you are digging deep, searching for clues, and trying to understand the bigger picture. It's about making sense of vast amount of information to get insights and make informed decisions. Well, this is it. We are at the end. I hope you enjoyed it, you liked it, and you learned something new today. And take care. Let's meet in another video.